Very good afternoon. This is Alok Srivastava, and here I am with a new video. The idea, not idea, basically, the objective of this video is to make you understand how the remove command works and how the shred command works. I can just write here. I will open my trusted G editor. So the basic idea is that advantages of using shred over remove command, that is the objective. We all use remove command. Every day we use remove commands. Very simple, just create a file for removing a file. We had learned in our RSC training or in our normal say trainings that we can use the remove command so that the file will be removed and can no longer be accessed. But I personally say that instead of using the remove command for removing any sensitive data, you should better use the shred command. So for understanding the shred, we should first understand how the remove command works. So let's me give you a very simple example of what actually happens when you create a file, what happens when you remove the file, and what happens when you shred the file. So I'll just start with the first thing. They say let's create a file. Let's create a file and see how the information about the file is stored. So I'm doing the first thing first. We are going to create a file and see how my Linux file system stores the information about the file. The second step will be we'll be removing the file using the remove command and see what happened to the data within the file we have removed. And the third thing that I'm going to show you is how the shred behaves with the file that you want to remove. Fine. So these are the very small things or very elementary things, but I personally think very important because lot of students, they feel safe after removing a file using the remove command. So let me first show you what happens when you create a file. Like here I'm using my Ubuntu machine, so that is not an issue. So I create a very small file, cat say zebra. This is a test file. I do a control D, job done. So if I do a LL here, you can see there at the bottom, you can see my file. I can view the contents by giving cat zebra, or I can see the inode of the file using the ll-i command, or zebra, or you can give ls-li. It's solely up to you. I have a habit of using ll, which is actually an alias for ls-l. So the zebra has got an inode associated with it, and this is the inode. So what happens and where the contents are, and when I say cat zebra, the contents will be shown to me. So let us first understand where the data is stored and how and what information is stored within the inode. So for this I am using a simple drawing tool, open source drawing tool, Pinta. Here it is. So let's understand what happens when you create a file. Okay, when I'm creating a file, so I can write here create file. My drawing is not that good. So here I had created a file zebra, and in my case, say zebra has been assigned a inode number, say 8888, just to make it easier for us. uh, Actually in my case the inode is 2242683, so I'm just to avoid writing that big number, I'm just assuming that it is 8888. So when I create a file zebra and there is a particular inode associated with it, here it is, I can just mark it like this. So what happens, it is actually going to a inode number. Let me change the color to make it more colorful. It is actually, just a moment, here it is, it is actually going to a inode number 8888, which contains a lot of information about the file. So what is the information stored? That is the timestamp of that file is stored. Then the user information is stored there. The group information is stored there. Your permissions are stored there. Size is stored there. It also stored, the most important thing is that direct block pointer. Direct, please bear with my handwriting, block pointers. That means where the data is, where actually the data is. So I'll just enclose it in a box. So all this information is stored at that particular inode. Now the direct block pointers is actually referring to the addresses where actually the data is stored, the contents of the file is stored. File contents, actual contents. It can be, if the file is small, it can be in a single block, or it can be in multiple blocks if the file is big. File contents. So it is the actual contents, the actual data is in the red blocks. And if the file is even bigger, then it can be pointed to a single indirect block pointers. You can also have single indirect block pointers. Block pointers in case the file is big. So what happens, that might be it is pointing to another block which might be pointing to the actual data location. It can be like this, that it is pointing to a different data block. I should not make it in red color, let me make it in green. So it is possible that it is pointing to another block pointer, and which might be pointing to another location where the actual contents are. So contents are in red color, file contents. Just to make it simple, just understand the first thing, that whenever I create a file, the file has been allotted a inode. That inode is actually the number that contains the information related to the file, include the timestamp, user information, group information, permission size direct block pointer, which is actually pointing to the actual file contents. It is what happens when you create a file. Fair enough. Now let me remove the file. So now what happened when you remove the file? I'll just open my editor. So the first step is done. So what happens when you remove the file using rm command? Nothing happens. When we remove the file, the data is not deleted. Let me make it a point. When we remove the file using the rm command, the data is not deleted. Only the index, remember this, only the index listing where the file is stored is destroyed. Data is still there. Data is still there, which can be recovered. That means what happens? Suppose you had given this file a command, say remove zebra. So when you give this command remove zebra, what happens? Let me go back to my drawing editor, Pinta. So what happen is that only these pointers get removed. Means if I remove the eraser, just to make it very simple, I am not going into the complexities of the file system, just to make you understand what happens is that only these pointers get removed. This is the eraser, I suppose. Yeah. So only these pointers get removed. These pointers get removed like this. These pointers will be removed. I am removing these pointers. So the pointers get removed like this. Means now the inode is not pointing to the data or to the actual file contents like this. These pointers will get removed. Now this inode or this name is not referring to any file contents, but the file contents are very much there. Remember this, the file contents are still there. This is a dangerous situation. The file contents are still there. The file contents are not lost. Only the link between the index is removed. Got it? It is what happened when you use the remove command. So I'm going back to the editor. So now that means that the data can still be recovered by using many undelete utilities, and it is possible. Remember this, it is possible. These utilities will try to reconstruct the index and can bring the file back if space is not reused. I can write here, if space is not reused. What does that mean? Look what happens. Go back to the Pinta. Now the contents are still there. Fine. Now what the operating system does, it will, when you create new file, it will first use the locations, those are free. So say this red block is already being filled with the contents, though the linking or the index is lost, but the contents are still there. Similarly, in your file system there might be many free spaces. Say it is, just a moment, say it is your free space available here. It is the hard disk free space. The green color is the free space. So first the OS will try to fill this free space. When this free space is full, only then the operating system will try to rewrite over the contents, rewrite the contents on this red blocks which already got some contents. Got it? So first the free space will be used. Once the free space is totally used, then these contents will be overwritten, but the priority will be that the free space will be used. That is why I had mentioned here, if the space is not reused, means if still the operating system is, you have got ample space here and the OS is writing the data here for 1 week, then even after 1 week, if this data block is not overwritten, then the chances are that you can still recover the data. So I can also make one point, say like in case of a very busy server means where the read write are often, where write activities are in good amount, then it is possible that the red blocks will be overwritten very fast, but you never know, when it had happened, but you never know that it had happened or not. Got it? So in case your data is very sensitive and you want that it should not be recoverable in any case, then instead of using remove, you should use shred. So I can point here, in case your data is sensitive and you don't want it to be recovered in any case, excuse me, then use shred. Or it can be helpful. Shred can be a help. Fine, that is great. Now let us see how shred works. What shred do? Okay, I'm going back to that, my Pinta. What shred does? When you use the shred, means if I use the command, say for example, I can use the command shred zebra. So what it does, and how it is more safe to use shred. So I can use the command shred zebra. So how it works? Simple. What shred does, I can write here and then I will explain you. Shred rewrites, uses many rewrites or shred, I can say rewrites over the data block with multiple data patterns. Right? To maximize the damage. What it does? Okay, let us see what happens in case the shred is not working. Suppose now the whole space is occupied, the free space is occupied. Now the operating system will try to write the contents over the data block that already contains the file contents. Means, let's say the original contents are in red color. Now the operating system will try to rewrite over it with the new data. I'm writing here new data. It goes something like this, new data. But still you can see the traces of the original files are still there. I can use many software tools that will try to read beneath the current layer to read the data. The green data is there, but still the older layer is visible. So I can mention it like this, new data. I can also, but the old data layer is still recoverable, new data, like this. So I can mention here in the point. So it is possible with remove command, it is possible to take the disk in a lab like we see in the movies, like we see in 007 movies, and use a lot of expensive hardware or equipment to look for any traces of old data under the overwritten data. It is what I had just shown you. It is possible. If the data is not overwritten once, it is not hard to recover. If the data is not overwritten once, it is not hard to recover. As you can see here, data is overwritten only once, but still you can see the red contents, the contents in the red color. So if it is overwritten multiple times, that means, okay, I'll use another color. See, another contents multiple times means data is overwritten multiple times means after the original data was red, then the new current is green, then the new is more more color, more new data. When it is written multiple times, then it becomes difficult for you to read the original red contents, right? So more the layers, more it will be difficult for you to sniff the original data in the red, even by naked eyes or by the software. Just try to understand the basics. So the best way to delete is, so what I found is the best way to delete a sensitive data is rewrite it multiple times. Rewrite over it multiple times so that the original data cannot be sniffed, right? That is the main thing. So it is exactly what the shred does. It is exactly what the shred does. It rewrites, as I had mentioned here, it rewrites over the data block with multiple data patterns to maximize the damage. It rewrite the data block multiple times with multiple patterns. Making it really difficult to recover. So what happens? What happens? So when I do a shred, now if I do a shred, now if I do a command, say shred zebra, what it does, let us see in illustration, like in an illustrated way. So shred, by default it rewrites 3 times, but you can increase the number. So it rewrites on this data. So I'm just undoing it. This is done, undone, 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 undone. So let's suppose it is the original thing, only one layer. But when you do a shred, it rewrites on the same data block multiple times with different patterns. Like suppose it rewrites like this for the first time, just a moment, like this, with a different data pattern, like this, like this. It rewrites multiple times. So it is the one time. Then it uses a different pattern, like this, rewrites on it, one more pattern. So by default it takes 3 patterns. You can increase it. So 2 patterns are there. Then it uses another pattern, say going like this, like this. So in this way it deletes the contents. Now you can see there, I had used the shred only 3 times, but it is very difficult for you or for any software to read the original data or sniff the original data. The same will be done for each block which is associated with the file. It is how the shred works. You can increase the number of patterns or the you want a file to be shred, but it seems safe. It is safe, but there are some exceptions. It is safe and work well on hard disks, but some exceptions are there. Like some file systems, like your JFS, general link file systems are there. General file system, you need to take care, like your ext4, AIX, XFS, etc. Then RAID, if the RAID is configured and you had removed one file, still the copy of that file is available on the other hard disk. RAID based file systems, so in that case shred might not work. And compressed file systems, shred might not work. So you need to take care of these things. Means in that case you need to look beyond shred. Means now you need to look beyond shred. It is, you can, in that case, in some cases you can even shred the whole file system, That means I can give the command shred /dev/sdx or whatever. So it will shred the whole device, the whole file system. But again, as I had mentioned, you need, in case of a very sensitive data, you need to take care that no remote copies of data is made. In that case, shred will be of no use. Got it? And so we had just understand the shred very carefully, what the shred works. Let me show you a very simple example here. I'll just go back to my terminal. Here we had created a file here, zebra, and I can still access the file zebra, and based on my drawing, the zebra is stored in the inode number 2242683. So whenever I am saying cat zebra, this whole logistics or the navigation is being done. I am saying cat zebra, so I am here. I am in say green color. I am harmless guy. So I am here. I am here. I give the command cat zebra. So it goes to this inode. It takes me here. From here it checks the timestamp, the permissions, user, group, whether I have got the permission to access the file, the size, and then it from this block it is taking me to this path. Great. And I am getting the contents on the screen. Now I say zebra, I say cat zebra. Now I say shred zebra. By default it shred the file 3 times. I can show you. I can give a -v, verbose. Here it is. Pass 1, 2, 3. Now, if I give zebra, it is what I am getting. It has overwritten the contents of the file. The inode is there, everything is there, but it has overwritten the contents. Everything is pointing here, but instead of the actual data, I had overwrite the data multiple times. In this case, 3 times. So now it is non-readable. You can increase the size, say by give say -n8, means shred it 8 times like this. So 8 different data patterns will be used. So more difficult to read it. Got it? Okay. So I hope you got this point. So now one way is that you can simply use the shred command, and then if you still find that this, then you can safely remove it if you wish, like this. Now you can safely remove the file. So first I had done the shred, after shred I had done the remove zebra. Now I am sure that the file is removed, as well as the data cannot be recovered by any software. But still there are expensive hardware and the labs from where they can take out, means they can take their your hard disk and will try to recover it. But in normal cases, under normal conditions, the data is not recoverable. So feel free to use shred for any sensitive data and try to remember the basic logic behind the remove command, how the remove works and how the shred works. And by the way, like I was just browsing through the net and I found this very beautiful software, that is BleachBit. It needs BleachBit is a software where that you can do to use the shred and remove your caches, your cache and your temporary files in a graphical manner. It's a beautiful software. You can just Google it, use BleachBit. So I had downloaded it from here, BleachBit. Feel free to download it for your distribution or the OS that you are running. So I had downloaded it for Linux. So it gives me this graphical interface, which gives me a very beautiful things like shred files, shred folders, and the best thing that what I found BleachBit does is that it helps me removing my cache files, my temporary files in a very efficient and a graphical manner. Like suppose I say free disk space, or say I want to free my cache, system cache. I can click here, I can do a preview. It tells me the whole information here. If I click on preview, it will show me what means files, actual files it is going to remove. Like suppose I move down here more in my system, look here, deep scans, my system is there, memory, I'm doing a cancel here, logs, just do a preview. So if you select that please remove the system log, so these files will be removed. It tells you exact location. Then it is solely up to you whether you want to shred them or wipe them or do whatever. So Feel free to use BleachBit. It's a total open source project which in a graphical manner will help you removing your temporary files like this. I do a preview here, so these files will be removed. If I do a shred, log rotates, deep scan your temporary files, I select the temporary files, the option is slow, fine, I'm not doing it. So feel free to use it, or you can manually use the shred command. I hope I was able to make you understand the difference between the remove, how the remove works, and how unsafe is actually remove command to remove your files if your data is critical, and how the shred can be of help. I hope you like the video. Thank you very much. God bless. Take care. See you again soon. Stopping the video now.